Okay, in this video I want to do a real quick example of how to use TInterval, the function on your calculator, for constructing confidence intervals. The reason I want to do this is on the exam you're not going to have a table of critical t-values to use to construct the interval by hand. I want you to rely on this calculator function to do it instead. The calculator function is in the stat menu, and then I'm going to go over to the test submenu, and it's the 8th item down in this menu, so I'm going to use the keystroke shortcut 8, and that brings me into the t-interval window. And you have two ways of inputting your data for a problem. The first way is when data is selected, and then it's expecting you to provide a list of raw sample data. Now that's the second example I'll do. The first one I'm actually going to go over and use the stat input window. So I'm going to click over to, arrow over to stats and enter. And you can see it requests a different set of input values. And this is the situation where instead of having a list of raw data to input, it actually gives you the sample mean and sample standard deviation. And for the problem I want to do, that's the situation. I'm going to look at problem 13 on page 431 in section 9.2. And you can see here it reads, a Gallup poll conducted on such and such a date asked 1,006 Americans during the past year, about how many books did you read? And the results of the survey indicate that of those 1,006 Americans, the mean number of books read was 13.4 with a standard deviation of 16.6. And you're asked to construct a 99% confidence interval for the mean number of books all Americans read during the past year. So in this case we're presented with the statistical or the descriptive statistics of the sample as opposed to having the 1,006 data points. So I'm in t-interval, I'm in the stat window, and I'm going to go down to x bar, which is the mean of the sample, and that's 13.4. Next I give it the standard deviation of the sample, which is 16.6. So there's apparently quite a bit of variation in the data. N is the sample size, which is 1,006. Confidence level that they are requesting is 99%. So I type in 0.99 and then calculate. And there's your confidence interval, 12.049 to 14.751. And we can say we are 99% confident that the population mean number of books read in the past year will fall within that interval. And then it gives you the data that we had input. Now the next example I want to do concerns being given a set of raw data and using the same function. So let me go back. What I'm going to do is go into the list window, and I'm going to put my raw data in for whatever problem I choose to do. Okay, so the problem I want to demonstrate this with will be number 24 on page 432 concerning battery life for iPods. And what you're given in this situation is the sample data from 10 full charges. What I'm going to do is take these numbers and put them into a list. So I'm going to pause the video and do that really quickly and then come back. Okay, I've gone ahead and entered the 10 data points into my list L1, and I'm just going to scroll down to show you and also to confirm that I entered those correctly. Okay, that looks right. So now what I want to do is go back into t-interval. So I go into the stat menu, over to tests, item number 8, t-interval. Now I'm going to switch over to the data window, and now you can see it's prompting me for the list containing the data, and L1 is already indicated, so I'm going to leave that. Frequency, leave it as 1, and then the confidence interval this problem asks for in part B is 90%, so I'm going to type in 0.9, enter, and then calculate. And what's really nice about this is it does everything for you. First you've got your 90% confidence interval, 8.2291 to 10.711. Your sample mean is computed, 9.47, as well as the sample standard deviation, and then it confirms that you entered 10 data points in your list. So there are two examples of using t-interval in two different ways. Z-interval is very similar to this, so I'm not going to go through that. It's simply the situation where you have a population standard deviation given. And t-interval is the situation where you don't have the population standard deviation, where you're working strictly off of your sample data. The next function I want to show you really quickly is going to be one prop zint, which is for constructing confidence intervals for proportions. And I'm going to scroll up in the bottom to get to one prop z int. Easy to confuse this one with one prop z test, so if you select that by accident and you don't recognize the inputs it's requesting, don't freak out. Make sure you've got the right function indicated. So one prop z int. Let me show you which problem we're going to use to demonstrate this function. Let's go to problem 11 on page 441 in section 9.3, and this is the question concerning Lipitor, and it says the drug Lipitor is meant to lower cholesterol levels. In a clinical trial of 863 patients who received a dose of Lipitor daily, 47 reported headache as a side effect, and we want to, in part C, construct a 90% confidence interval for the population proportion of Lipitor users who will report a headache based on this sample. Now if you look over here at the calculator function, one prop z int, it's only requesting 3 inputs. Basically we need to pick out x, which is in this case the number of patients who did report a headache, n would be the sample size of the study, and then c is the confidence level. So in this case we have x is 47, let's see, 47 patients out of 863, because that's the number of patients who reported a headache, and that's the population proportion that we want to model here. Next we're going to go to confidence level, which is 0.9 again. I'm just typing that in even though it's the same. And next we want to calculate. And those are the only 3 things that you have to input. And we are given now the 90% confidence interval for the population proportion who will report a headache based on the results of the sample. And that is 0.04176 to 0.06717. So that's about 4% to about 6.7%. And the sample proportion, the 47 over 863, is about 5.4%. And again, our sample size that we gave it was 863. So that is how you construct a confidence interval for population proportion using one prop z int.